Okay, I am back. I was in the middle of doing my video and all of a sudden Zoom popped up and showed that it had disconnected. And so I am doing a part 2 to this video. And so back to my story about gas permeable eye contacts. I told you back in the 90s, I had got my first pair when I was in the Marines of my eye contacts. And I remember they were actually pretty thick compared to today's contacts, how they're very thin and easy to move around. Well, I was wearing these contacts. They told us we could wear them up to 7 days without having to take them out. You could sleep in them, and that you could take them out after 7 days and you could clean them very well and then put them back in. Had no issues with them. They were great. Loved it. But I remember after a while, I don't know how long, I guess maybe a year, when I went and seen the eye doctor again, and they told me about when they were looking at my eyes, they said, how often do I take my contacts out? And I said, well, once a week, because they're extended wear. And so my doctor at the time told me I need to take them out more because my eye blood vessels were actually moving in the whites of my eyes, and they were actually moving towards the outside of my eye, trying to get around the contact, basically, out from under the eye contact, because the eye contact was extended wear, but it was really thick, and it did not allow gases or oxygen to properly permeate through the contact to get to my eye. And so they actually stopped offering these extended wear contacts, but the doctor could actually see my eye blood vessels that they had moved, and they were trying to get oxygen. So they moved out from behind the contact and were going towards the edges of the contact where the contact would have been on my eye in order to get oxygen. So that was a shock and a surprise, and nothing happened to my eyes, thank goodness. And so I stopped wearing those type of contacts. And of course, now they have really good permeable contacts that work very well. And I take mine out every day and clean them, and do not sleep in them unless I accidentally fall asleep with a nap. Okay, so that's my personal story about permeability of gases and how the importance is, especially with eye contacts. Okay, the next property is compressibility. High pressures can squeeze gases into small volumes. An example of this could be when you go and put air in a tire, okay? Air in a tire. And so you're thinking of, we've got PSI, pounds per square inch. If you drive a car, you have a PSI rating on your tire, and it tells you to put in so much gas in there will cause a pressure buildup. And we can squeeze a whole bunch of gas in that tire until it becomes really taut and solid, as you feel it. And so we want a good amount of air in our tires when we're riding because it saves on gas mileage. And in a minute, I'll have a picture of what I'm talking about as far as your tires. The next property of gas is expansibility. And gases expand to fill their containers. They expand without limit. So again, if I had a gas and I released it, it would try to fill the whole air, the whole room, okay? If I opened a window, then the gas would fill out and then actually go outside and continue to expand. So as long as they can expand, they will expand and become limitless. Okay. Here's an example of the tires I was talking about. This is some good information for you, especially if you drive, and if you don't drive yet, you will. When you are driving, you should check your air pressure once a month, minimum, especially in Florida, when we have the weather that jumps down to 50-some degrees in the evening and up to 90-some in the daytime, so we can have some big fluctuations. And here is an example of a tire. If it's underinflated, it doesn't have enough PSI or enough air pressure, what happens is it basically spreads out a little bit and more of the area contacts the concrete, the highway or the road, and you start to see wear on your tires more often on the outside and on the inside. Here you have overinflation. Now you have too much air, too much pounds per square inch in your tire. Some tires take 32 pounds per square inch, 42, 45, any of that. If you have too much, now you've overinflated it. So usually this is going to be kind of bowed out a little bit. And this is going to be contacting the road more often than your outer tread. And so this will wear out. And then it shows the correct, if you have it in your perfect PSI that you're supposed to have for your tire. So you should check it at least once a month, because your tires automatically just slowly lose air. And especially if you have a big weather change, cold to hot, when it gets cold, you lose pressure because the molecules slow down and fills the tire up less. And if it gets really hot, then they can expand and actually overinflate your tire. So there are some important things you need to learn about your tires, and this is a good way to maintain them. And if you have the correct tire PSI, it helps you with gas mileage. You save money on gas, because here there's a lot of drag on the road and a lot of maybe not this as much, but it's worse wear on your tire. But this one actually has a lot more friction on the road, and so it causes your gas mileage to be less. More often than not, we get underinflation because our tires do lose the air. Okay, another property, 6, fluidity. Gas particles can flow and be poured. So if you remember at the beginning of the year, we had our dry ice lab, and we used it to pour some of that dry ice gas out onto the candle and put it out because it's made of carbon dioxide. And so, of course, carbon dioxide does not encourage a flame to burn, but we'll put it out. Okay, gases and pressure. Pressure, the average force exerted per unit area within a boundary. And so the pressure is the force per unit area within a boundary, like a balloon. How much force is being pushed on inside that balloon? We have different units of atmospheric pressure. So we're at atmospheric pressure at sea level in Florida. So we're not high or below, we're like right at sea level. And so these units work well for us because this is the typical standard measurement. So we have some measurements. We've got 14.7 pounds per square inch, or you could see the initials PSI. And so what that means is for every square inch, 14.7 pounds are pushing down in the atmosphere. So think about that. That's a lot of pressure pushing down. We have another one called millimeters of mercury that they can use in barometers and things to do our atmospheric pressure. It's 760 millimeters of mercury. We have another one called torr, 760 torr, which is another measurement. These are just different measurements. And then we have 1 atmosphere, okay, which is at sea level. These are all standard pressures. And so just like we talked in our previous lesson where we could use 1 mole of anything equals its mass, or 1 mole of anything equals Avogadro's number, 6.022 times 10 to the 23rd. You can look at these all as ratios that equal each other, all at sea level. They all are equal to each other in that we could do ratio and conversion problems with them. Conversion factors. Okay, so here's some of our factors we've got, okay, which we just talked about. And here's another one with kilopascal, and we've got Pascal, PA. So we could make conversion factors of any of these, whatever problem we need to solve. So if you got 1 atmosphere and millimeters of mercury, comparing with them, we would use this ratio. We could use it this way or flip it, inverse it, okay? Here's an example of a problem on your paper. You want to make sure to write this out so you know how to do these problems. 1.20 atmosphere equals how many millimeters of mercury, okay? So we're using atmosphere and we're using millimeters of mercury. So all we got to do is look at our conversions. We are using atmospheres, the standard is a 1, and we're using millimeters of mercury. So we need the 760 millimeters of mercury. So this is our given. And so then we're going to put this over here, our find, and then underneath it, we're going to put atmosphere because we have to measure it, okay, or match it, right? Okay, so we've got our 120 given atmosphere. We're converting it to millimeters of mercury, so we use the number for 760. And then we're matching our atmosphere on the bottom so we can cancel it out. And that is a standard of 1 atmosphere. So you're just using these ratios. And we would multiply the top, divide by 1, which is itself, okay? And we would come up with 912 millimeters of mercury. So these problems are very easy. They're not long conversions like 3, 4 steps like the previous problems. So very simple, easy. Hopefully this is a nice breath of fresh air. Okay, I'm going to go ahead and finish this video because it's been about 20 minutes. And I'm trying not to have you watch over 20 minutes because I know you have 7 classes. Okay, you guys take care, and I'll be back for the next recording.